I have spent over a decade exploring how technology can transform architecture, moving us from static spaces to environments that truly interact with us. And looking 50 years ahead, we will see cities that breathe, evolve, and learn alongside us. DNA, or dynamic neural architecture, is an architectural movement that envisions building as dynamic entities. Architecture that thinks, feels, and evolves with its inhabitants. So imagine a future where buildings are not just shelters, but living entities, constantly adapting to our needs and emotions. The core of dynamic neural architecture is the idea of cognitive synchronization. Spaces that connect with our very thoughts. Think of AI-driven adaptation or enhanced reality and self-healing materials. These concepts might sound futuristic, but they are rooted in technologies we are developing today.
Hello everybody, today we are exploring the future of design and architecture with Professor Imad. Imad, I have a few questions for you. You are known for pushing boundaries of architecture and design. What drew you into the concept of transhumanism?
You know, most people think architecture is all about designing spaces for the present, but I have been always fascinated by designing for the future. So transhumanism grabbed my attention because it's not just about where we are now, but it's about where we are heading. Transhumanism is about enhancing the human experience using technology to push beyond our biological limits. For me, it's not just a theory, it's reality we're stepping into. I'm working on projects where the goal is to design environments that can adapt to and even enhance human capabilities, like spaces that respond to our emotions, rooms that adjust their configuration based on our needs, or even homes that can sense and react to our physical and cognitive states. Imagine an architecture that goes beyond the four walls, buildings that know you, spaces that grow and change with you. That's the kind of future I want to design.
That's a bold vision. But with such innovation, there are often come fears. What about technophobia? How do you see it playing into your work?
Oh, absolutely. Whenever you push the envelope, there are always going to be a bit of resistance. Technophobia is real. It's that fear of technology taking over. I mean, people might be concerned of losing control or even losing touch with our humanity. But here is where I think it gets interesting. Rather than seeing this as a barrier, I see it as a design challenge. How do we create environments that embrace technology without alienating people? How do we design spaces that feel safe, warm, and human, even as they integrate the latest technologies? In my projects, I'm exploring ways to make buildings feel less like cold machines and more like companions. Architecture that understand privacy, that respect personal boundaries, and that make you feel secure, even as they offer the best in smart technologies. It's about designing for trust.
That's a fascinating balance. On the flip side, what about technophilia? How does this love for technology influence your design?
Technophilia is where the fun begins. I think of it as the flip side of technophobia. The excitement, the enthusiasm for what technology can do. It's about embracing innovation, not just for its own sake, but for what it can genuinely improve in our lives. So take my current work, for example, where I'm experimenting with smart homes. So I can explain, it's like a living partner, spaces that learn your habits, that can play your favorite music when you walk, or adjust the lighting based on your mood without even you thinking. And we are also experimenting designing urban spaces that are interconnected with real-time data to make them more efficient and enjoyable. So the key is to balance that excitement with practicality, I would say. Just because we can automate everything doesn't mean that we should. It's about finding that sweet spot or the right balance where technology enhances life without overpowering it.
Well, now let's dive into hyperreality. This concept is blowing up, especially in the digital age. How do you see hyperreality influencing your field so far?
Hyperreality is where things get really wild. Imagine a world where the line between what is real and what is simulated is so blurred that you cannot even tell the difference anymore. And we are already seeing it with virtual reality and augmented reality and these digital filters that transform our perception of reality in general. So in architecture and design, it means we are no longer just creating physical spaces, we are designing experiences instead. So these experiences exist in both the real and the digital world, and I'm currently working on concepts for hybrid spaces that seamlessly integrate augmented layers over the real world. So we're designing for dual reality now. This is how I like to refer to it, dual reality. And that is an incredible, exciting space to be. And because it allows for endless creativity and you're no longer constrained with the physical limitation of material or even the structures.
Ahmad, you have got me on the edge of my seat with all these ideas. The question is, how do you tie all those concepts, transhumanism, technophobia, technophilia, hyperreality, into your architectural vision?
Well, it's all about creating a new language of architecture, one that is dynamic, responsive, and deeply connected with both our biological and technological evolution. And I call it dynamic neural architecture or DNA. So my goal is to design buildings and environments that are as alive and adaptable as we are. Spaces that can think, feel, and evolve with us. You can take transhumanism, for example. I want to design environments that cater to enhance humans, where walls could become interactive canvases for our thoughts, or furniture that adapt to our needs real time. For technophobia, I would focus on creating safe, empathetic spaces that gently introduce technology without overwhelming people. It's about humanizing tech, I would say. On the other hand, technophilia drives the innovation, pushing us to see how far we can go by integrating AI or Internet of Things and many other advanced systems into everyday's living. As for hyperreality, that's where I blend the real and the virtual designing experiences that are equally flexible and captivating. I see a future where architecture is not just built out of bricks, but also made with pixels and data streams, where a single space can offer multiple realities. It's about creating a future where our environments are not just static backdrops, but dynamic participants in our lives. So it's a thrilling era, and really I cannot wait to see where it's going to take us.
Ahmad, you are known for shaking up the world of architecture. What inspired you to create this concept, dynamic neural architecture, DNA?
What if buildings could think? What if they could respond to us, read our moods, adapt to our needs, and even anticipate our next move? I wanted to take it a step further. Imagine buildings that are so smart they can actually have personalities. I thought, why not create buildings that are alive, that have a pulse, that can feel the energy of the city and the people also. And this is where DNA was born. A crazy out there idea to create architecture that is more like a living organism than just a bunch of dead bricks. And I wanted people to feel like they're in a relationship with their surroundings, where every space they enter is a new experience. And it's tailored just for them. Because honestly, why not? Why should our buildings be any less exciting than our lives? So let's make them wild, let's make them unpredictable, and just a little bit crazy.
What do you mean by building are static and so predictable?
Think about it. We live in a world where everything around us is getting smarter. Our phones, cars, and even our refrigerators adapt to us, learn from us, and respond to our needs. But what about the places where we spend most of our lives? Our homes, offices, and schools are static and passive. They don't change, don't learn, and they certainly don't feel. So I realized that we need buildings that are as dynamic and alive as we are. That was my light bulb moment. Buildings that think, feel, and evolve with their inhabitants. That's where the concept of dynamic neural architecture, or DNA, came to life.
So, what does DNA means for someone like me, just going about my daily life?
Great question. So imagine you are waking up in a home that knows you almost better than you know yourself. It senses you had a rough night's sleep, so the bedroom gently brighten with warm colors and calming music start to play. Your living room change into, or basically your living room changes its ambience to match your mood. Cooler and quieter if you're stressed, or warmer and more vibrant if you're ready to start the day. So it's like having a home that is synchronizing with your emotions, responding to you in real time, helping you feel more at peace, more creative, and most importantly, more yourself.
That sounds amazing, but so futuristic. How do you see this working technically?
Well, it is futuristic, but definitely it's not science fiction. We are already making strides with AI, neural interfaces, and smart materials. So think of it this way. We use sensors and bioresponsive materials that can detect your brain waves, your heart rate, and even the skin temperature. And these sensors communicate with the neural AI systems that adapts the environment. And I'm referring here basically to lighting, temperature, textures, and color, and all based on how you are feeling at any given moment. So it's like your space becomes an extension of your mind and constantly adjusting and evolving.
Can you walk us through how DNA could be achieved? What does the roadmap look like?
I would say we have to start first with the research and development. And the first step is going to involve a deep research into neuroscience, AI, and advanced sensors technologies. So this is going to include developing neural interfaces that can accurately read brain signals. We need also bioresponsive materials that can adapt their properties in real time, and algorithms that process vast amounts of data to understand human emotions and psychological states. The second step will mainly be focusing on creating a prototype. So we need to create small-scale controlled environments to test the technology and gather data. So think of it like a pilot project, like a single room or a small office space where we can experiment with neural responsive materials, adaptive lighting, and temperature control, and study how users interact with the environment. So the goal is to refine the technology based on real-world feedback. Moving to the third step, we need to work on interdisciplinary collaboration. Basically, we have to collaborate with people from variety of a background. This is not a project for architecture alone. So we need to bring together neuroscientists, AI specialists, material scientists, engineers, and even artists. So collaboration across disciplines will help us understand how the integration, or basically how to integrate these technologies seamlessly into architecture and make them functional, sustainable, and aesthetically pleasing. Once we finalize the three main steps, we're gonna start with developing standards and protocols. And I'm sure we need specialized people for this part as well. Because as we build these prototypes, we must establish standards and protocols for safety, privacy, and ethical use of data. Because it's crucial to ensure that the technology respects privacy and maintain a high level of security, especially when dealing with sensitive neural and biometric data. Once we finalize these steps, we're gonna start with scaling up to larger projects. I would say once the technology and design principles have been tested and refined, the next step is to scale up to larger projects. Residential buildings, office complexes, hospitals, and eventually the entire neighborhood. And why not the whole city? Each new project will provide more data and insights, helping us improve the technology and understand how it works in different contexts. Once finalizing all of these, I believe we need to keep in mind a continuous learning curve to evolve. Dynamic neural architecture isn't a one-time implementation. It's an ongoing evolution. The system will learn from the occupants and adapt over time, just like a living organism. This means continuously updating the AI algorithms, upgrading the materials, and refining the architecture to ensure it remains responsive, intuitive, and beneficial.
Imad, practically speaking, how would you approach executing this concept?
Execution is all about integrating technology seamlessly into everyday life. We start by designing environments with hidden layers of technology, walls embedded with sensors, floors that can detect movements and temperature. So surfaces also that change textures and color based on the time of the day or even the emotional state of its occupants. We're also exploring biodigital interfaces, lightweight neural bands, or even implants that can communicate with the building. Imagine simply thinking about needing a quieter space to work, and the room automatically adjusts its acoustics, dim the light, and even changes the wall color to help you focus. So the goal is to make the technology as invisible and intuitive as possible. So it feels like a neural extension of the space rather than just a set of gadgets.
And what about design philosophy? How do you keep it human-centered?
Well, that's at the core of everything. DNA is about creating spaces that connect deeply with human needs and emotions. The design philosophy is centered around empathy, understanding the unique ways people experience and interact with their environments. It's about creating spaces that support mental well-being, foster creativity, and offer a sense of safety and comfort. We want buildings that don't just stand around us, but live with us, spaces that are truly alive.
So, Imad, what's next for you and dynamic neural architecture?
I'm just getting started. I want to collaborate with neural scientists, AI experts, architects, and designers worldwide. I want to experiment, prototype, and test these ideas in real spaces. Most importantly, I want to inspire people to see their environments differently, not just as a place to live in, but as partners in their daily lives, evolving and adapting with them.
Any final thoughts for those curious about DNA?
Well, I would say keep an open mind and imagine the endless possibilities. The future of architecture is about creating spaces to feel more human, more alive. Let's build a world where our environments aren't just around us, but a part of us. That's the promise of dynamic neural architecture.
We look forward to share with you more of those new exciting ideas and the challenging they are waiting for us in the next future. Thank you, Imad.
Well, thank you so much, Professor Eduardo, for receiving me today and giving me the opportunity to share a bit of what we are doing, the kind of research that we are developing. And I believe that maybe our audience will be interested and curious to know more about how this technology is going to reshape and change the way we see our environment, our cities, our neighborhood 50 years from now. And I think to predict the future, we're going to start working on implementing it today.